Hello everyone, welcome back to Manufactoria 22 is the name of this game. There are 4 puzzles left before we reach the end game, I guess. We could just do this one, Fusion Tender. But I wanna like try and do that last if I can. So I'm not even gonna read the text. If you read, you're cheating. I'm gonna look at Eden Builder here. I've heard people talking about this one in the Discord, just sort of ambiently. Haven't looked at any of the spoilers, obviously, but I assume this one must be somewhat difficult if people are asking about it. Maybe it's addition. The robots had designed a huge array of construction machines along with accompanying photos of a vast, gorgeous paradise city. But there was no one there yet. No humans, not other robots, just endless scaffolding and construction. What were they waiting for? Okay. Ah, comparison. Right. How do I do that? I wish I could like load up my solution to the old one. But, you know, it's fine to do it again. I mean, the most important bits to look at are like the most significant bits, right? But you can't just like look at the first bit and if they differ, then choose a winner, right? Because it might be like one of them is 10 and the other is 00111 or something, right? Or 10 here is 2 in binary and the other one is 7. But neither can you, like, you can't just remove all the leading zeros of both solutions either, can you? And then decide. Because they would obviously both start with 1 in that case. But then you would look at the next one, and if they differed, you still wouldn't know. Right? It could be 101, or it could be like 10 versus 110. No, versus 11. No. It could be like 11, i.e. 3, versus 100. In that case, the second one should win, and it's a 4. Now, what you might be able to do is like throw away whatever prefix they share, their shared prefix, and then check which one of them is higher in the first digit that they don't share. And then just remember that information forever by transitioning into a different state where you remember that. And then compare them for length. If they're the same length, you take the one that differed first, right? Whoever won the first digit comparison. If they're a different length, then the longer one wins. Now, you have to make sure to also strip leading zeros from each of them to apply that technique. But you might not have to do that first. Because when you're comparing length, the way you're going to do it is by removing one token from each of them, right? Like remove one from the left and one from the right. If you fail to do so in either step, you'll know which one was empty. Or possibly both. And while you're doing that, you can say, I'm gonna ignore zeros at the front. But I guess that's not true, because you only want to... If you have a loop where you're removing the first digit, you can't, at the beginning of that loop, like, at the beginning of an iteration of that loop, remove a bunch of zeros, because those matter. I feel like you do want to just pre-process them both by removing all the zeros, even though I kind of hate it. Are you going to give me any inputs that look like that, by the way? Can I have 0, 1 greater than 1? Yeah, that's allowed. Okay. And it'll say no. So you do have to handle that. But it's not especially hard to handle. It just, like, is a little bit wasteful of space, scanners, and stampers, and so on, right? So I think we can just do that. So step 1, stamp on... What does our yellow look like, by the way? Is it plus? Yeah, see, that they're warning me the next time, this next puzzle we're gonna have, or some puzzle soon, we're gonna have addition coming up. Okay. But I don't know, it's probably better to just use green. For some reason or other. And now... Ugh. Removing leading zeros from both of them kind of sucks. Is there some way I could get around that? It's really hard. So we throw away blues until we get to a red, and then we copy everything. There can't be a green here, actually. Yeah, there can, if the whole input was 0. Oops. And then we copy reds and blues. Until we get a green. So, I've pruned the first number. Now I have to do the same for the second number, which I think is just exactly this. Because I don't need to write the green again, so I can do that basically, right? Or I guess I could do that if we want to save a little area. So let's just test with, you know, blue, blue, red, blue, greater than red. So run me the test until here. Something isn't right. Oh. I forgot to copy the first red as well. That's not quite what I want. I want it like this, right? I can't reach this green from here. Hang on, I can also vertical mirror it. Like that, right? Oh, that looks so good. Is this really accomplishing what I want? It's so beautiful. And then I just want the same thing again, right? Do I vertical mirror it? No, that doesn't help because it doesn't save me any actual space. Because this entry point has something above it and below it. I could rotate it, I guess? So right now I'm writing 10 to 1, right? And if I run this test, going, yeah, 10 to 1. Is 10 greater than 1? Yeah, so that's perfect. Is it good on space or is it wasteful on space? I guess we'll see. I kind of suspect it's wasteful. Like, I'm not going to want to go up over to the top area, maybe. I'm going to want to go down here. Like, what am I going to do with this space? Basically nothing, right? So I should try to leave this row clear for future stuff. Let's grab this and put it back where it kind of looks obviously like a copy of itself, right? Oh yeah, this is kind of a funny... I guess this is a sufficient specification, isn't it? Oh wait, inputs can't be empty, but they can still be just 0, so I kind of need to handle empty anyway. They can just be a bunch of zeros, yeah. And they have exactly 1 green, and this actually uniquely specifies all valid arguments to this, like, all valid arrangements, right? The meaning of these and the greater than sign is not relevant to deciding what is a legal input. Oh, they can actually all be empty, right. It's one total, at least one symbol, which could just be the greater than sign. Okay. So... now that I've trimmed them, I want to compare the first digit of each. It is possible for either one of them to be empty, because they could have been all zeros, so I will need to account for that. So... so let's say this, right? What I want to do after this is copy the original, the leftmost input, and remember the first digit I saw, which is this. And if it's empty, I feel like in that case I can do the same thing as if the first digit was a 0. Wait. The first digit can't be a 0. Because I trimmed them all. So the first digit is definitely red in both of them. So I guess what I have to do is not look at their first digits, but basically iterate through them each one digit, iterate through like a digit index. 0, then 1, then 2. Look at the 0th digit of each, and if they're the same, keep going. And then look at, to look at the first digit of each, and so on, the 1th digit. And then the 2th digit, and so on. As soon as I find a difference, then I check, are the two digits even? Are the two numbers even the same length? If they're not, the longer one wins. Okay. So all that said, can I treat a green here like the same as a blue here? I guess I can, right? I would have to stamp well, no, because a green here is going to need to move on to the next number. And a blue here needs to copy until it sees a green, thinking that that's the number it's currently working on. And if I just stamp a green back after finding a green here, it'll be in the wrong place. So I can't collapse those two cases together. If I run into a green, I basically... Oh, I just junk it, don't I? Because I don't know whether they're the same length, but I sure know the first one is not bigger than the second one. If I compared their digits and they were all the same until the first one ran out of digits, the second one definitely is not smaller. So we can just junk here. Now we can get out our trusty friend, the red-blue copying device. This is... Well, no, I was going to say this is why I should vertical mirror it. But if I do, there's a problem here instead. Well, okay, let's program this bottom side then, first. And then just copy it to the top. So we copy reds and blues until we get to a green. Then we stamp the green back on and continue working. I wasn't meant to copy this, although I guess it would have been fine. So I guess what I wrote is not very exciting. But there you go. I want to keep them mirrored so that it's easier to copy paste if I need to. Make sure I don't accidentally walk into space the other one doesn't have. And if there's dead space later, I just eliminate it easily. So we found a red at the beginning, and we copied the remaining digit. And now... we look... at the first digit of the next one. Like so. If it's blue, we need to go to the length comparison with left wins semantics. Oh, I can't even reuse the length comparison because they both... oh, the worst. But if it's red, then these two are the same. And what I need to do next is copy to the next green and then put a green back. which I think is this node. Yeah. And so likewise here, if it's blue, oh, wait a minute, that's the opposite of what I wanted. I had to, this goes here. I just want this to get to here. How, is that too much to ask? Do I just have to push this even farther right? I kind of hate it a lot. Maybe I'm going to give up on minimizing stampers, but that's my sort of default position, so I'll at least try it. So we've already made a lot of progress here, right? We've trimmed the inputs both to not have any leading zeros. And now we're comparing them until we find a difference. If there was no difference, we just junk. Because we know the answer is not greater than. It could be equal, it could be less, but it can't be greater. So that leaves these two cases where there was a difference. Either the first one was blue and the second red, or the first one was red and the second blue. And so I guess all we have to do is like do two length comparisons, right? I'm never coming back to this input space, it turns out. I guess I knew that. But I'm only coming back here twice, and I've already done both of them. Through here, right? Well, I guess I'm not quite finished, because what if the... What if the right one runs out first? If the left one is a red, as down here, we can just accept. But in the case of the finding a blue on the left and then the one on the right running out, we need to see whether there are any ones left. No. I don't care if there's any ones left on the right, on the left number, because these zeros are meaningful. They're at the end of the number, not the beginning. So I have like 10 versus 1. I know 10 is bigger than 1. So I can just accept here also? This is the first number running out. This is the second. And we know the first number didn't run out because we didn't get here. The first number has something in it that isn't a 0 because we stripped leading 0. So it must have at least one digit that's a 1 at the beginning of it. And then it has more digits than the other one does. So it's definitely bigger. Okay. That's nice to have those handled. Now I actually do just have to do length comparison twice. A lot of unused space over here. It sure would be nice, wouldn't it? But what is it? Let's build an area comparer. Right? With a length comparer. We have found a difference in our two strings, which means we've read the same number of digits from each of them, right? And I'm now looking at the remainder of the right string. So, if that's empty, oh gosh, there's so many stupid cases. If that's empty and left isn't empty, then left wins. If they're both empty, then it's a tie. No. If they're both empty, then left wins, because this is the case where we found red on the left and blue on the right. Okay, so maybe this isn't so bad to write. So here's our comparison that's going to go at the bottom here. I'm writing it separately, and then we'll move it into place. We look at a digit, and we don't even care what it is. But if it's empty on the right, then whether the left is empty or not... Oh, I can't just accept here, right? I have to... Yeah, I can. I don't... It doesn't care what's on the tape, just whether I accept or reject. Okay. So if what's on the right is empty, then they have the same length. Well, left is at least as large, and furthermore, its first digit is a 1. So I can just accept. But if the right had a digit, then I must copy the remainder of right and see if left had a digit. I could just write red for both cases, but I think I'll be true to the spirit of the thing and copy what was actually there. So I copied the remainder of the right number. We'll call that B, I guess. L and R might be better. I copied the remainder of R and got to its green stamp. Now, I don't necessarily have to write that stamp back yet. I'm going to have to put down a stamp for it, but I can save a tiny bit of time by not doing it unless I have to. Now I can look at L. If L is empty, and R was not empty, then it doesn't matter what digit how they differed in their prefix. R is bigger because it's longer, and therefore L is not greater than R, and I can reject. But if I found at least one digit in L or R, in L, then I need to write a green to end R and then copy L, right? So, and then I need to get back here. So that's the end of R. And then I get back here. And in this case, I need to do the same thing. Well, I can save myself a little time, I guess. Like that. And this doesn't have to go higher in that case, because I'm coming in through here, not here, so okay, great. So this, I believe, is finished for this. Where's the entry point? It's anywhere along this top edge, the one that has the green on it. So I can just dump it here. And I have to do something very similar here. Except I have to replace one of the accepts with a reject somewhere. Okay. Get out of here. I do not desire you. It's this that I want to copy, paste, and vertical mirror. And place here? Something's not right. Am I like not building in the center? I guess maybe I'm not. It doesn't matter because this entire section happily is equivalent. Okay, so which of these is the one that I have to replace? I could, if I were truly confident I built everything correctly, just hit run. And when it tells me I have a mistake by accepting something I shouldn't, I'll just put junk in there. But I'm not at all confident that what I have is correct, and that seems like a kind of reckless way to test. Well, I guess I could save some area, actually, by moving that thing further down. This saves me one tick of time, but this saves me an entire row of area to move it down. So let's do that, I guess. So, if the first input started with blue, and the second input started with red, wait, that's not right, is it? What's happening? What did I do here? So, if the first input started with blue, copy. And the next input started with red, that is what's happening here. Ah, right. I've consumed an equal number of digits from each of them. And so it's okay that I'm looking at, like, just a single digit of R. Because I know that if they're equal, they'll have the same number of digits, and I can just start on R now instead of going back to L. Okay. So if R ends here, I can't... wait. I can't actually accept or reject in that case. Because... I know that R's highest digit was higher than L's highest digit. But well, if R is empty here, right? If R is empty, then L is bigger if and only if it has another digit. Okay, maybe I shouldn't try to copy paste this. They're different enough. Okay. Maybe I'll try to build in this direction. I don't know. I mean, I could have done that over here as well. I used a lot of vertical space that could have been horizontal space I'm already using. So let's do that, shall we? So L's first digit is lower than R's first digit. Now we're going to look at R's next digit. And if there is no further digit, we just have to look at L's first digit. If there isn't one, then L was definitely smaller. Because it has fewer it has the same number of digits, but the first one is the lowest significant digit is there's some digit in them. Their highest significant different digit was higher for R than L, so I can reject. And if R ran out but L didn't, we accept. So only if now we handle the more common case where R didn't run out, right? If R didn't run out, then we copy the rest of R. And check out the first digit of L. Does it have a digit? Does it exist? If it doesn't have a digit, then we can reject it because R had more digits. If it does, then oh, I have to get all the way back here? Yuck. Oh, I can't even do this because I have to get to here. Okay, here we go. I can copy. Oh, don't I need to write a green somewhere in here? The green for R that I deferred writing? I need to write it here. Now I get to... I've finished copying L, and so I should write its green. And get here. Okay, it's obviously correct. Any human with a brain could look at this and say, oh, obviously, it's comparing two numbers. Let's just run it. Okay, I was worried it was going to be right there, which was... I was intending to be... what's the word for... I mean, facetious, I guess, but a little bit more... I was brash, claiming my solution was obviously perfect. So it's kind of interesting that the first input that it found fault with was 10 versus 111. So 2 versus 7? You couldn't complain about 2 versus 6 or something? I don't know. So what happens here? We copy them both. That's all fine. Just go to here, please. Wait a minute. Why does running it to here run it through here and back around? Anyway, we still have 10 versus 111, so that's fine. We read the first red and the first red. No, we read the first red. We copy the remainder of L. So there's our 0. Then we stamp L. And we look at R and we say, yep, that's a 1. So they were equal in their first digit. We copy the remainder of R. And we stamp it back out. Now we're comparing 0 to 1, 1. That obviously should lose, right? We see a blue, and we copy the rest, which is nothing, and we stamp a green. And we look at red. And I say, oh, look at that, they were different. So now I'm remembering that I want to compare their lengths, and R wins ties. So I look at the first digit of R, and by God, it is a digit, all right. I don't care what it was. I copy the rest. There wasn't any. Should this be a junk? I feel like this should just be a junk, right? Because R has a digit, and L doesn't. You gotta admit, I was pretty close when I said my solution was self-evidently correct. I was just missing this one little thing here. Obviously the area is atrocious. But I feel like I hopefully did well on scanners and stampers. What could I have improved? I don't know. Eden was designed to be a luxury city, and its builders were looking for a buyer. No one, human or robot, could afford to buy an entire luxury city. But if the robots broke it up and sold it by parts, it would lose value. They spent more and more resources building Eden higher and higher. Perfect, beautiful, and useless. Ah, look at that. 56 is the scanner and stamper goal. I've used 13 fewer. So let's see if I can make a quick improvement on area. And whether I can or not, that'll be the end of the episode. So my thinking was, like, all of this, I could do that, right? Yeah, I mean, that's better. I'm sure more improvements are possible. Well, like, for example, if all we care about is area, then we can improve this some more, right? This whole thing could go up here, right? It's not quite as good for time, but it works. And we're actually close to the area goal, believe it or not. This is a little bit tougher to bring down, though. I can bring it a little down, I think. This bit here goes left down when it could have gone down left. So that, I have that for wiggle room. And that's the goal, right? 192? Oh, but I broke it. Rip. How did that happen? Oh, this I think was meant to go through here. Let me undo this. Yeah, this has to go through. It has to reach here, right? So it used to look like this. This was before I messed with it. This pipe went through to the scanner. And this bit went down. And now that I'm done, the pipe doesn't go through to the scanner. No, it does, doesn't it? It goes to here. Let me just double check. This is still correct somehow? Yes. And this is wrong. Yes. How? Oops. Looked outside the window there. I could just look at the problem, but it's patently, like, obvious that this... What has changed here? Ah, I didn't copy this. I see. That and also this need to move down. Hey, okay. I'll take it. I got the area. I think I have a few too many conveyor belts to try to prune for a better time. Yeah, I think we'll just declare victory on this one. And that'll do it for this episode. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.